What's up? What's up? It's your man Jimmy Chan. All right, so we have an endangered species of fish decreasing exponentially. The population 9 years ago was 1,500. Okay, so let's go ahead and write that down. 9 years ago was 1,500. Today we have 1,000 of fish that are alive. Awesome. Okay. So why don't we go ahead and actually, with this piece of information, actually figure out what my decay rate is, or decreasing rate is, right? So so I would still use A is equal to A naught E to the KT. So my final amount is 1,000 because that's today. But it started off at 1,500 E to the K times T, and the T it was 9 years ago. So it's going to be 9T. So I would divide off the 1,500. So I'm going to have 1,000 divided by 1,500, and that's going to equal to E to the 9T. So what I need to do here is I'm going to have to take the ln of both sides. All right. And what I have here is T. Oops, sorry. Nope. This is not T. This is actually K. Sorry, guys. Because T was the 9 years. So K is actually going to equal to ln of, I can reduce this to 10 over 15. Actually, I can reduce it less than that. No, you know what? Let's do this, guys. Let's go ahead and write this whole thing out as 1,000 over 1,500, okay? Divided by 9. All right, so that's my K. And if I was to plug that into the calculator, let's see here. So I have this. The top is the ln of 1,000 divided by 1,500 divided by 9. So there it is negative 0.045. So it's about negative 0.045. Okay. So now, if you look at it, it says, today, only 1,000 fish are alive. Once the population drops to 1,000, the situation will be irreversible. So if you notice that this gets repeated, right? But what I don't know is that in the future, right? Which means this is going to be what? Years from today, right? Or toady. Years from today, right? It's going to be 100. But I don't know how many years, right? I don't know how many years. So that means I'm going to have to use this formula again. But now that I know how it's decaying, so let's assume that it's going to keep on decaying this at the same rate, right? Clearly, we haven't done anything the last 9 years. What if it keeps on going this way? Let's, can we fix this problem? How many years do I have to try to fix this problem? So again, I'm using the same exact formula, except my final amount that I'm afraid of is going to be 100. And today is 1,000. But I know what my K is this time, but I don't know what my T is. My K is this negative 0.045. But I need to know what my T is. That's what I'm looking for. So the same idea, I'm going to go ahead and divide off that 1,000. So I'm going to have 100 divided by 1,000 is equal to E to the negative 0.045t. And again, I'm going to take the ln of both sides. So from here, what's going to happen is that e is going to cancel out. I'm going to be left with negative 0.045t. And I'm going to divide it off. So this is going to tell me that t is going to equal to the ln of 100 divided by 1,000 divided by this negative 0.045. And let me see, I want to round it to the nearest whole year. Okay? All right, so let's go ahead and plug that in. Now, don't forget, guys, I already calculated this part, right? So let's see what I do. All right, so let's go ahead, and that part's right here on top now. So again, I have a fraction. The top is going to be the ln of, oops, don't need another of, 100 divided by 1,000. Oops, ooh, hee, la, 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 divided by 1,000, parentheses, and it's going to be divided by that previous answer. And look at what I got here, 51.1. So it's going to round to 51 years from today. So that is going to be choice C. And there we go. I hope that helps. Any questions? Let me know. See ya. Bye.